In this demo, you are going to build a Terraform module for managing DNS and SSL certificates, focusing on AWS Route 53 for DNS management and AWS Certificate Manager for handling SSL certificates. This module is important for setting up secure, encrypted connections to your website and ensuring that your domain's SSL certificate is correctly configured and validated. Your first step will be to create a folder for your module and write the main Terraform code. In your module, you'll incorporate a data source to dynamically fetch the Route 53 zone ID, enhancing the automation and efficiency of your setup. You'll focus on avoiding hard-coded values, using variables for the domain name and DNS record time to live instead. You'll also define important outputs, like the SSL certificate's ARN and the Route 53 zone ID, to keep track of key resources. They'll be crucial for other modules in later parts of your configuration, ensuring your setup is interconnected and efficient. Once your module is set up, you'll integrate it into the main Terraform file at the root of your project. Here, you'll reference your module and pass in the necessary variables. You'll then take care to add the necessary details to your Terraform variables file, or tfvars, and then commit these to your module. This method makes your Terraform configuration cleaner and reduces the need for numerous environment variables in your CI/CD workflow. After ensuring your Terraform variables file is securely saved in your repository, you'll initiate Terraform, push your module to GitHub, and observe as your setup comes to life through an automated process. After deploying your infrastructure, you'll first verify your setup using the AWS Management Console, checking the AWS Route 53 and ACM to ensure everything is configured correctly. Then, you'll turn to the dig command to further validate your DNS configurations. Dig, which stands for Domain Information Grouper, is an invaluable tool for querying DNS name servers. It helps confirm the accuracy and propagation of your DNS records. Let's get started. Start by confirming that you are in the root directory of your project. You can do this by running the pwd command in your terminal. Now create your second module using the mkdir command. This will be the module that encompasses the creation of SSL certificates and the necessary DNS validation in AWS. In the terminal, enter mkdir-p Terraform /modules /route 53 _ACM. Move into the newly created directory using the cd command. Create the essential module files using the touch command. In the terminal, enter touch main.tf, touch variables.tf, touch outputs.tf. Now you will proceed by defining the necessary resources for the module. In the Route 53 ACM directory, open the main.tf file. Then, with a right-click, open the variables file, and select Open to the side. Close the Explorer panel. Close the terminal. And then adjust the dividing line between main.tf and variables.tf to optimize the workspace for your needs. Refer to the video description below, and open the link to the Route 53 ACM main configuration reference file. You will find that the Terraform resource blocks required for configuring DNS and SSL certificates have already been compiled for you. These resource blocks are sourced from the Terraform registry. However, the task at hand requires you to manually fill in the attributes for these resources. Copy the code to your clipboard, and proceed to paste it into the main.tf file. The code begins with a data source block. This tells Terraform that you're defining a data source, which is used to gather information about an existing object outside of Terraform's management. It's read-only and does not create or manage any resources. By specifying the AWS Route 53 zone, you're telling Terraform that you want to retrieve information related to a Route 53 DNS zone. After the data source block, you will then notice an empty string enclosed in double quotes. This is where the local name is given to this data source instance. It's a reference handle you will use within your Terraform configuration to access the properties of the retrieved Route 53 zone. Enter DNS_zone within those double quotes. The name attribute specifies the name of the Route 53 zone that you want to retrieve information for. In this case, you will use a variable to specify the name of your domain. In the variables.tf file, enter variable root_domain. Ensure the variable is enclosed in double quotes, and then add curly braces to the end. You can reference this variable in the name attribute by typing var.root_domain. The private zone attribute indicates whether the hosted zone is a private zone within AWS. Setting this to false means that you are looking for a public DNS zone, which is accessible over the internet. Proceed to the AWS ACM certificate resource block. The goal is to create an AWS Certificate Manager certificate that can be used to enable HTTPS on your domain. Next, give your resource a name. Inside the double quotes, enter SSL_certificate. Now, set the domain name attribute to specify the primary domain for the ACM certificate. Use the variable placeholder root domain. Enter var.root_domain. The subject alternative names attribute is a list that allows the certificate to be valid for additional domain names. You will set this to include all subdomains of the root domain. Begin by typing square brackets. In Terraform, brackets are used to define a list. Since subject alternative names expects a list of strings, it needs to be enclosed in brackets. Inside the brackets, start your string with double quotes. This tells Terraform that what you're typing is a string. Inside the double quotes, insert the wildcard character. This wildcard is used to represent all possible subdomains. Immediately after the wildcard, add a period without any spaces. The period separates the wildcard from the actual domain name. Together the wildcard and period implies all subdomains of. Now, you'll add your root domain variable to the string. Type curly braces for variable interpolation, and append var.root_domain within these curly braces. This tells Terraform to insert the value of the variable root domain into the string at this position. By constructing this Terraform expression, you request an SSL certificate for not just your root domain, but for all its subdomains as well. This approach is efficient and widely used for securing multiple subdomains under a single certificate. Set the validation method to DNS to specify that DNS records should be used to validate ownership of the domain. This is the method ACM will use to send challenge requests to prove you control the domain. Inside the double quotes, type DNS in uppercase letters. Inside the lifecycle block, set create before destroy to true. This instructs Terraform to create a new certificate before destroying the old one during updates, which helps in preventing downtime. Proceed to the AWS Route 53 record resource block. This creates a DNS record in AWS Route 53. Next, give your resource a name. Inside the double quotes, enter DNS_validation. Set the allow overwrite attribute to true. This allows Terraform to overwrite this DNS record if it already exists. This is useful for updating an existing record without manual intervention. The name attribute refers to the name of the DNS record that you need to create for domain validation of the ACM certificate. This DNS record name is provided by AWS as part of the certificate's domain validation options. Begin by typing to list, followed by parenthesis. This function is used in Terraform to convert a set or collection into a list. Inside the parentheses of TOList, type the reference to your ACM certificate's domain validation options. You can find these from the previous resource block. Type AWS_ACM_certificate SSL_certificate. Then append the domain validation options attribute. Type domain_validation_options. This attribute contains the details AWS ACM needs to validate your ownership of the domain. After converting the domain validation options to a list, you need to access its first item. Since lists are zero indexed, the first item is at index 0. You can do this by typing 0 inside square braces, immediately after the closing parenthesis. The object of this index contains several pieces of information, but you're interested in the resource record name, which is the name of the DNS record AWS expects for validation. Access this by typing resource_record_name. By writing this line, you're instructing Terraform to create a DNS record with the specific name that AWS ACM provided for your certificate's domain validation. Now, let's set the records attribute. This attribute defines the value of the DNS record required for the ACM certificate's domain validation. Start by typing an open square bracket. This indicates the start of a list, as the records attribute expects a list of values. Inside the square bracket, begin with typing to list, followed by an open parenthesis. Now type AWS_ACM_certificate. Then a period, followed by SSL_certificate. This references the SSL certificate resource you defined earlier. After SSL certificate, type period, then domain_validation_options. This accesses the validation options of the SSL certificate. Then immediately after the parenthesis, type 0 inside square brackets to access the first item in the list. Next, type a period, followed by resource, underscore, record, underscore value. This specifies the value for the DNS record that AWS ACM checks for validating your domain. This entire expression inside the square bracket sets the DNS record's value as provided by AWS ACM. By setting this attribute, you ensure that the DNS record you create matches what AWS is looking for to validate your domain. Next, you will define the type attribute. This attribute determines the type of the DNS record required for ACM certificate validation. Begin by typing to list, followed by an parenthesis. Inside the parentheses, reference the SSL certificate resource you've defined. After SSL certificate, add another period and then type domain, underscore, validation, underscore options. Immediately after the parenthesis, type 0 inside square brackets. Continue by typing a period, and then resource, underscore, record, underscore type. This part of the expression fetches the specific type of DNS record required by AWS ACM for validation, such as CNAME or TXT. Setting this attribute correctly ensures that your DNS record is of the correct type for AWS ACM's validation process. Proceed to setting the zone ID attribute. This attribute specifies the ID of the AWS Route 53 hosted zone where the DNS record will be created. Start by typing data followed by a period. This references the data source, which is used to fetch data from a provider. Next, type AWS underscore Route 53 underscore zone, then another period. This is specifying that you're accessing information about a Route 53 zone. Now type DNS underscore zone, followed by another period. Here, DNS zone is the name you've given to the Route 53 zone data source in your configuration. Finally, type zone underscore ID. This will retrieve the ID of the specified Route 53 zone, which is necessary to create your DNS record in the correct location. By setting this, you're ensuring that the DNS record for ACM certificate validation is created in the appropriate Route 53 hosted zone. The final attribute to set in your AWS Route 53 record resource is the TTL, or time to live. This determines how long DNS resolvers are allowed to cache the DNS record. In the variables.tf file, enter variable DNS underscore record underscore TTL. Ensure the variable is enclosed in double quotes, and then add curly braces to the end. You can reference this variable in the TTL attribute by typing var.dns underscore record underscore TTL. By setting this attribute, you define how long the DNS record should be cached, impacting how quickly changes to it propagate across the internet. Now, let's configure the AWS ACM certificate validation resource block. This resource is used to automate the validation of the ACM SSL certificates using DNS. Begin by giving your resource a name. Inside the double quotes enter SSL underscore validation. Proceed to the certificate ARN attribute. This attribute specifies the Amazon resource name, or ARN, of the SSL certificate to validate. Reference the ARN of the SSL certificate you created earlier. Type AWS underscore ACM underscore certificate period SSL underscore certificate period ARN. This links the validation process to the specific certificate you want to validate. Proceed to the validation record attribute. This attribute will hold the fully qualified domain names, or FQDNs, that AWS ACM will check for DNS validation. Start by typing an open square bracket, and inside the square bracket, type AWS underscore route 53 underscore record period DNS underscore validation period FQDN. This refers to the FQDN of the DNS validation record you've set up previously. By configuring this, Terraform will ensure ACM checks the specified DNS record for validating your SSL certificate. After setting up your AWS resources with Terraform, you need to output certain values, like the SSL certificate ARN, and the Route 53 zone ID. These outputs can be useful for reference or for use in other parts of your Terraform code. Select the variables.tf file, and then open the Explorer file. In the Route 53 ACM directory, open the outputs.tf file, and close the Explorer panel. First, create the output for the SSL certificate ARN. The ARN of the SSL certificate is a unique identifier for the certificate that you created with the AWS ACM certificate resource block. To output this, you can add an output block and reference the ARN of the certificate directly from the resource. Start by typing output. Then name your output inside double quotes. Type SSL underscore cert underscore ARN. Add curly braces to the end, and press enter. On the new line, type description, followed with an equals sign. Then inside double quotes type the ARN of the SSL certificate. Press enter, then type value, followed by the equals sign. The value field contains the actual data you want to output, which in this case is the ARN of the SSL certificate. Here, enter the reference to the SSL certificate's ARN. This can be found in the AWS ACM certificate resource block. Type AWS underscore ACM underscore certificate period SSL underscore certificate period ARN. Similarly, if you want to output the zone ID of your Route 53 zone, you'll create another output block. You'll reference the zone ID from the data source you've set up to fetch details of the Route 53 zone. Proceed to line 6 and type output. Then inside double quotes type Route 53 underscore zone underscore ID. Add curly braces to the end, and press enter. On the new line, type description, followed with an equals sign. Then inside double quotes type the ID of the Route 53 zone. Press enter, then type value, followed by the equals sign. Next, reference the data source type and data source name. Type data, period, AWS, Route 53, zone. Period, DNS, zone. Period, zone, ID. Zone ID is the attribute of the AWS Route 53 zone data source. It holds the ID of the DNS zone in AWS Route 53. In the next task, you will reference your Route 53 ACM module in the root module's main.tf. Doing so integrates the functionality of the Route 53 ACM module with your overall Terraform configuration. Select the main.tf window. Open the Explorer panel. And in the Terraform directory, open main.tf. Close the Explorer panel. Proceed to line 26 and begin by typing module. This keyword is used to define a module in Terraform. After module, add a space, and then name your module instance. Use double quotes and type DNS _ ACM. After the name, enter curly braces. This brace starts the block where you'll define the module's properties. Press enter, and on a new line, type source followed by an equals sign. Source tells Terraform where to find the module's code. After the equals sign, in double quotes, type the path to your module. Add a space, use double quotes, and type period, /modules. /Route 53, ACM. Next, you need to declare and pass Route 53 ACM variables to the root module's main.tf. Even though the variables are defined within your Route 53 ACM module, you need to pass values to these variables from your root module to effectively utilize and customize the module. This is a fundamental aspect of how modules work in Terraform and is key to achieving modular, maintainable, and scalable infrastructure as code. On the right-hand side, select variables.tf, and copy both variables to your clipboard. Open the Explorer panel, and then in the Terraform directory open variables.tf. Close the Explorer panel, and paste the variables from your clipboard into the file. Now in main.tf, pass the root domain variable. On the next line, type root _domain, followed by equals. Then type var, period, root _domain. Similarly, on the next line, pass the DNS record TTL variable. Type DNS record TTL followed by equals. Then type var, period, DNS record TTL. By following these steps, you're telling Terraform to incorporate and configure the Route 53 ACM module as part of your overall infrastructure defined in main.tf. This allows for the modular and organized management of your infrastructure components. Let's now add the values for the root domain and DNS record TTL to your Terraform tfvars file. This allows Terraform to automatically load these variables when it runs. First, select the variables.tf window, and open the Explorer panel. Locate the Terraform tfvars file. Once opened, you can close the Explorer panel. To define a variable, simply type the variable name, followed by an equals sign, and then the desired value. On line 5, type root_domain, followed by an equals sign. Enter your domain within double quotes. Next, let's add a line for the DNS record TTL variable. On the following line, type DNS_record_TTL, followed by an equals sign and the value 300. A TTL of 300 seconds is typically a suitable starting point for DNS validation records, balancing prompt propagation and server load. Recall that in part 3 of this project, you handled sensitive data securely by adding variables as secrets in GitHub Actions, and referencing them as environment variables in the workflow. This setup provided necessary access to these variables during workflow execution. However, for non-sensitive data, committing the Terraform tfvars file to your repository offers a more efficient approach. It streamlines the Terraform configuration and reduces the need for a multitude of environment variables in your CI/CD workflow. To include your tfvars file in your next Git commit, modify your gitignore file. Select the main.tf window, open the Explorer panel, and open the gitignore file. Close the Explorer panel. Comment out the lines 16 and 17, which reference the Terraform tfvars file. This change will ensure that your tfvars file is included in your repository, making the variables available for your workflow. With your Terraform tfvars file now being committed to the repository, having the same variables set as environment variables in your GitHub Actions workflow is redundant. Removing unnecessary variables simplifies your workflow configuration, making it easier to understand and maintain. Open the Explorer panel. Open the GitHub workflow file, then close the Explorer panel. Delete the lines defining environment variables that correspond to those now in your Terraform tfvars file. Ensure all the modified files are saved in your local workspace. In the top bar, choose File. And in the drop-down, choose Save All. Now that you've made the necessary changes, the next step is to commit these changes, and push them to your GitHub repository. This will trigger the GitHub Actions workflow and deploy your Route 53 ACM module. However, running Terraform init in your local environment before pushing changes is a fundamental part of the Terraform workflow. Open your terminal, and then use the cd command to navigate to the Terraform directory. Execute the Terraform init command. Running Terraform init locally helps verify that your Terraform configuration is correct, and that all modules and providers can be loaded without issues. It's a good practice to catch potential problems early before they reach the CI/CD pipeline. It also ensures that your local environment matches what will be run in your pipeline. This consistency is crucial for avoiding the "it works on my machine" problems. Use the git add command to stage all the changes you made for committing. Navigate to the root directory, and then enter git add, followed by a period. Commit your changes with a message that describes what you've done. Type git commit -m. And in double quotes type, implemented Route 53 ACM module. And committed Terraform tfvars. Push your commit to the main branch on GitHub. As soon as you push your changes, GitHub Actions will detect the change in your repository and start the workflow associated with the push event. You can monitor the progress of your GitHub Actions workflow directly in the GitHub repository under the Actions tab. This will show you real-time progress and logs of the workflow execution. If everything is configured correctly, your GitHub Actions workflow will execute the Terraform commands to deploy your Route 53 ACM module based on the updated configurations. Once the workflow completes, verify that the changes have been successfully applied and that the Route 53 ACM module is functioning as expected. Begin by logging into the AWS Management Console and navigating to the Certificate Manager service. Within ACM, you'll find a list of your certificates. Click on this certificate matching your root domain, as specified in the var.root_domain variable. Check the certificate status. An issued status confirms successful validation and activation. ACM lists the specific CNAME record needed for domain validation, including both its name and value. Take note of these details. Copy the CNAME record for later use. Remember, ACM certificates require association with an AWS service for renewal eligibility. Next, navigate to the Route 53 service. In the left navigation pane, choose Hosted Zones. Select the hosted zone corresponding to your domain. Ensure the CNAME record from ACM is present and correctly matches ACM's requirements in both name and value. For additional verification, command line DNS queries can be useful. Use NSLOOKUP on Windows or Unix systems, or dig on Unix-based systems. Keep in mind that DNS updates may not be immediately visible due to propagation times. If you've recently added or updated a CNAME record, allow some time for global propagation. To perform a check in the terminal, type dig. Paste the CNAME record, and then add CNAME at the end. The output indicates that everything is set up correctly on the DNS side for ACM validation. The status, no error in the header, indicates that the DNS query completed successfully without any errors. The important part is the answer section. This section shows the result of your CNAME query. The 300 in CNAME part indicates a TTL of 300 seconds, which is the time period for which this DNS record can be cached by DNS resolvers. The presence of the correct CNAME record in the answer section means that you have successfully created the DNS record required by AWS ACM for domain validation. With this record in place, ACM can verify that you control the domain, and proceed with issuing your SSL/TLS certificate.